All right, so we just looked at how we could solve the nonlinear systems in the graphical way. Now we're going to look at it algebraically. Now this is actually going to be a little bit different compared to what we did before. If you recall, before what we did was we just set the two equations equal to each other. But now we can't do that because of the fact that there's going to be one equation where it's going to be y equals and another equation where it's y squared equals. So there's actually two different methods that we can use. We could use the substitution method or we can use the elimination method. Typically for the elimination method, that one's better when we have two terms, like either both of the x terms or both of the y terms, having the same exponent. Instead, we're going to actually focus on the substitution method. So let's say that we have these two equations. We have our nonlinear equation, and then we have our linear equation. Now, we can't actually, this one's actually going to be tough to graph because 17 is not a perfect square. So the way we're going to do it algebraically is the first step is to take our linear expression or whatever we have y equals to, maybe it's a quadratic, and plug it into our nonlinear equation. Um, if it's not already written as y equals, we have to make sure we do that first. So when I take the negative x plus 5 and plug it into here, I end up getting this. X squared plus negative x plus 5 squared equals 17. Now step 2 is solve for x. So I'm going to take the negative x plus 5 squared that we have and rewrite it so it looks like this. Because remember, when we square things, we're multiplying it by itself twice. So I'm going to distribute the negative x to both terms and the 5 to both terms. So I get negative x times negative x, which is x squared. I get 2 negative 5 times x. And then I get a 5 times 5, which is 25. So this is what it looks like. I can combine like terms to get this. Subtract the 17 over. Since I have a leading term of 2, I'm going to divide all the other constants by 2. And now I could just solve this. This is factorable. If I factor this, I get x minus 4, x minus 1, because negative 4 and negative 1 multiply to get 4 and add to get negative 5. Now that we have the factors being set equal to 0, I could just set each individual factor equal to 0. So I end up getting x equals 1 comma 4. So those are my x terms. And then the last step is just like before, we're going to take these x values and plug them back into our equation. I prefer the linear equation, and then we're going to solve for y. So I'm going to take the y, the 1 and 4, plug it into my linear equation. So when x equals 1, y equals 4, and when x equals 4, y equals 1. So it just so happens for this one that my two solutions will be 1 comma 4 and 4 comma 1. Those are going to be the 2 points where they cross. All right? And that's pretty much what you're doing. So you're going to take your linear equation, rewrite it so it's y equals, and plug that into your nonlinear equation for the y squared. You just need to make sure that you expand the y squared part properly. So here's our first question. Pause the video, work itself. I'll go over in a second. Okay, so first thing that I want to do is I actually want to clean this up a bit. I'm going to divide all my terms by 2. I get x plus y equals 5. And then when I rewrite this, it becomes y equals 5 minus x. This is actually going to take a while. I then take this equation, plug it in for y up here, so I get x minus 3 squared plus 5 minus x plus 2 squared equals 16. So this is x minus 3 squared plus 7 minus x squared equals 16. Now, if you don't know, one way that you can actually quickly do expand this is you can remember that if you have ax well, I'll just say it's x minus a squared. Then the expansion is going to look like, I'll make this positive, 2 times ax plus a squared. So I'm going to use that to make my life a lot simpler and to save some room. So here it's going to be x squared plus 2 times these two being multiplied, so negative 3x. And then I'm going to take negative 3 square it, which is a positive 9. And I'm going to do the same thing here. 7 squared is 49. Add 2 times 7 times negative x, so negative 7x, plus x squared equals 16. Combining like terms, I have 1x over here, 1x squared and 1x squared over here. So I have 2x squared. This is negative 6x, and this is negative 14x. So this ends up adding to negative 20x. And then I have a 9 and a 49, which will get me plus 58 equals 16. Subtract the 16 over, and I end up getting 2x squared minus 20x plus 58 minus 16, which is 42. I can divide all my terms by 2. So this ends up becoming x squared minus 10x plus 21 equals 0. Now I need to find two numbers that multiply to 21 and add to negative 10. Those two numbers are going to be negative 3 and negative 7. They both multiply to positive 21 and add to negative 10. So this becomes x minus 3 and x minus 7. Now that it's equal to 0, I can then set each term equal to 0 and find that my solutions for x are going to be 3 comma 7. Once I know that, I can plug 3 and 7 into my linear equation. So I can plug it into this first one. So it's going to be 2 times 3 plus 2y equals 10. 6 plus 2y equals 10. 2y equals 4. Y equals 2. So one of my solutions is going to be when x is 3, y is 2. Do the same thing, but now x being 7. So plug it into the same equation. So this is 14 plus 2y equals 10. When I subtract the 14 over, I end up getting negative 4. So I end up getting y equals negative 2. So my second solution is 7 comma negative 2. Now, one thing I want to point out is the reason I actually decided to use the original equation instead of this slightly altered form, even though this would have been much quicker, is just because I want to make sure that in case I made a mistake, I plug these answers into the original equations to see if I get the same answer. Because if I plug it into this altered equation, it may work here, but if I made a mistake getting to here, then I won't be able to catch it. So I like to always put it into my original. All right, here's the next question. Pause the video, work itself, and we'll go over in a second. All right. So for this one, what we're going to do is I'm actually going to add y over and subtract 8. So my equation becomes y equals x minus 8. Again, I mainly do this because I want to make sure that my y term is positive. It doesn't have to be, but do what you want. So when I do the same thing, I take this, plug it into my nonlinear equation, I get this. So now I have x squared minus, and if you remember, I can expand this quickly by just doing x squared plus 2 times negative 8x plus 64 equals 144. When I combine like terms, I get x squared minus x squared. So these actually cancel each other out. And then what I'm left with is a 16x minus 64 equals 144. Remember, you distribute the negative over. When I get to here, there's actually a bunch of things that I can do. What I'll do first is just move this over to the other side. So I get 16x equals 144 divided by 64, which is going to be, or sorry, not divided, plus 64, which is 208. Divide both sides by 16, and I get x equals 13. When I plug it into my equation, x minus y equals 8. I get 13 minus y equals 8, which when I do this, I'll get negative y equals negative 5. Divide out negative 1, I get a positive 5. So my solution set will be when x is 13, y is 5. So they're only going to cross at one point, and it's this specific point. All right. Here's the last question. Again, we're in the independent practice, so pause the video, work stuff, and we'll go over in a second. All right, so same thing. I'm going to subtract this x over here. 5 minus x. Plug it into here, so I get x plus 3 squared. And then I'm going to end up getting a y, oh sorry, I'm going to get a 5 minus x minus 3 squared equals 53. This expands out to be x squared plus 2 times 3x plus 9. This, when I actually combine this, this will become 2 minus x. So this will expand to be 4 plus 2 times negative 2x plus x squared equals 53. Combine like terms, x squared and x squared. So I get 2x squareds. This is a 6x. This is a minus 4x. So this combines to be a positive 2x. 9 plus 4 is going to be 13 equals 53. Subtract the 53 over. And I end up getting 13 minus 53. So my quadratic becomes 2x squared plus 2x minus 40 equals 0. Divide all my terms by 2. And I get x squared plus x minus 20. This can be factored into x plus 5, x minus 4, because 5 times negative 4 gives me negative 20, and they add to positive 1. So my x solutions will end up being negative 5 and positive 4. So putting both of those into the linear equation, I get this. So over here I get negative 5 plus y equals 5. So adding the 5 over to the other side, I get y equals 10. So my first solution, when x is negative 5, y is 10. And for the next one, it's going to be 4 plus y equals 5, y equals 1. So my last solution is 4, y is 1. And there we go. That's pretty much it. Once again, the whole idea is that you have to take your linear equation, have it y equals whatever, plug it into the original or non-linear equation. The trickiest part is to expand this. Again, if you remember this little shortcut, it will make expanding it a lot quicker and easier. But if you can't remember that, go back to the way I used to do it, where I go x plus 3 times another x plus 3, and then you distribute. Because one of the common mistakes I'll see people do is they'll write this as x squared plus 9, completely forgetting that you have to actually multiply x plus 3, x times 3, and 3 times x, and then add those two. If you have any questions, feel free to let me know, message me on Remind, join the extra help, ask me in class. Otherwise, I'll see you later. Good luck and have a great day.